Students, let's start our discussion regarding the p block elements we are going to discuss right now. We are discussing about the 17th group elements. Then the 17th group elements, we are going to discuss about the halogens only. We are going to discuss about the halogens only. Do you know very well halogens are, look at the here, look at the group 17. This generally they are belong to the 17th group. They are called as halogens only. In this halogen we are going to discuss in detail only. First of all, remember what is meant by halogens means. Halogens are salt former. Halogens are salt formers only. Generally halogens are, you know very well, fluorine, chlorine, bromine, iodine, acetylene belongs to halogens only. We'll discuss regarding the halogens in detail. Okay students, the first one is look at the is considered here. First one point is look at the period table is there. In this period table is there, no? Here in this period table, it's 17th group element is there. Generally there belongs 17th group elements are there. You can also 7th A group elements are there. They look at in this period table is there, no? They look at in the this is noble gas elements. Before the noble gas elements, halogens available. Generally halogens is there, no? Fluorine, chlorine, bromine, iodine, acetylene is halogens only. Once again repeating, fluorine, chlorine, bromine, iodine, acetylene is considered as a halogens only. Generally they are look at the left hand side of the, you consider right hand side of the period table only. Look at the right hand side of period table, last corner to be available only. Clear? In this one region consider the left hand of the halogens means salt formers only. Already you know very well. Look at some details regarding halogens only. What is mean by halogens? Halogen metals compounds are salts. General occur in the sea and water only. You know very well, NaCl is there, no? Sodium chloride which is present in the ocean only, no? Magnesium chloride, calcium chloride which produce hardness of water. You know very well. Nothing but halo means salt, sea salt. Gene is the bone former. Nothing but salt formers are called as a halogens. Once again repeating, salt formers are also called as a halogens only. Halogens means salt formers only. Okay, next one is states of halogen. Generally halogens are there, what physical state is available where they mention here there. First of all, look at the fluorine. You know very well all halogens are generally fluorine, chlorine, bromine, iodine is diatomic molecule. Diatomic molecule means look in order to form a molecule, 2 atoms are required. For suppose look at one molecule of fluorine taken means 2 fluorine atoms are there. One molecule of chlorine had taken 2 atoms of fluorine will be there, like a bromine and iodine. Look at the color. General fluorine is the yellow color. Chlorine is the greenish yellow color. Chlorine is the greenish yellow color. Bromine is brown color. Red or brown color will be there. Iodine is grey color. Iodine is the grey color will be there. Next one state is there. Now fluorine is a gas. You know very well. Fluorine is available in the gas only. Chlorine also gas. And one point remember the last one question, which is the liquid metal available in the period table? Nothing but liquid non-metal. Nothing but here bromine only. Iodine is solid only. Iodine is solid only. When we do the vaporization process, it becomes vapors are there. Look at them, if they make a vapor, is a bromine vapors will come here. Iodine vapors is there. General chlorine vapors will be considered like that. Generally we are not taking fluorine means fluorine is explosive only, that's why we are not taking it. And also remember acetylene is radioactive elements. And acetylene is a radioactive element and is one of the rarest chemical, general rarest element only, very less radioactive element, generally not available in the earth crust only. So that's why only we are not discussing in detail regarding it. Look at students, once again look at here, there consider the generally I'm discussing states of halogens. In the states of halogens I'm discussing about the physical state of halogens. The color itself giving idea about iodine purple, look at the iodine purple color, brown color and greenish color is there. So these are regarding the halogens only. Look, next one is look at the consider the halogen means generally Greek name is there. Fluorine is coming from flora. Generally it's one flow. Chlorine is there, no? Chlorosis, greenish yellow gas generally. Bromine is bromos, stench. Iodine iodos, violet color is there. Acetylene is acetanous. Generally they are available in the acetylene place there, no? Generally the decaying product is uranium and thorium. When our acetylene undergo decomposition process, you will get the uranium and thorium is the radioactive elements. You will get it. Okay, you will get those elements are there. Next one, general properties of halogens, very very important. General halogens are having 7 electrons in the outermost shell. Because of having 7 electrons in the outermost shell, halogens are more electronegative atoms. They readily takes electrons from the elements. That's only you can see the most of the halogens are minus only, F minus, Cl minus, Br minus, I minus. Why means they need 1 electron to attain the octet configuration. So next one is they exist as aspects of separation diatomic molecule. Look at consider that they exist as a diatomic molecule. Even the fluorine, chlorine, bromine, iodine, they are available in the diatomic molecule only. colored, and generally consider the colored and color of the darkness as shown. We go down the book because mention is the colors. They mention already discussed about colors. Fluorine is the yellow color, chlorine is greenish yellow color, iodine is violet color, bromine is brown color only. They are non-metals. You know very well generally halogens are non-metals only. Do not conduct electricity. You know very well non-metals are doesn't conduct electricity. Next one is never found in free nature. Look at the consider one point is there no most react to metals, most react to non-metals, never ever available in the free state. They are always available in the form of the combined state only. Generally chlorine is found in the NaCl. Okay, NaCl only. Generally they are poisonous only. Generally consider chlorine gas is a pungent gas will come. You know very well when you add with any salts, when you add small amount of sulfuric acid, chlorine gas liberated, you have some pungent smell will be there. They are all toxic and harmful because they are so reactive. They are toxic and harmful because they are more reactive only. They are more reactive. Do you know very well chlorine gas is used to kill the bacteria? Okay, to purification of water, there is a chlorine gas they will be used on. Next one, general electronic configuration of halogens on. This is very very important. General electronic configuration of halogens. If you take the fluorine is there, no, it's containing the 1s2, 2s2, 2p5. Look at the 2s, 2p5 means how many electrons are there? 2 plus 5 is 7 electrons are there, no? Its valence is 7 only. If suppose if you get 1 electron, you attain the neon configuration. So what happens there? Fluorine is the most electronegative element in the period table. Fluorine is most electron. Fluorine never available in the plus. Always available F minus only. Next one is the fluorine electron configuration is 3s2, 3p5. Bromine electron configuration is 4s2, 4p5. Iodine electron configuration is 5s2, 5p5. Astatine is there now here 4f14, 5d10, 6s2, 6p5. If you have any doubt to write electronic configuration, mention here the helium 2s2, 2p5. 2 is there mention 3. 3 is there mention 4. 4 is there mention 5. 5 is there mention 6 only. Clear? So after 3p by 3p is there 3d will come. Okay, after 4p 4d will come. After 4d 4f 5d will come. That's the electronic configuration. Very easy electronic configuration. So these are electronic configuration only. Look at it, they have the 5 electrons in the outermost shell. That's the reason why they are more reactive non-metals. More reactive non-metals present in the period table. That's are halogens only. Those are the halogens only. Next one is look at the next one is generally halogens are there. No, most of the halogens are like that. Fluorine and chlorine are the fairly abundant, while bromine, iodine is the lesser. So then consider the chlorine generally available. General chlorine is there. No, ocean water we take. If you take ocean water containing NaCl 2.5%. 2.5% is weight. So NaCl, calcium chloride, magnesium chloride, whatever the chlorine will be present only. Next one is the fluorine is present mainly as insoluble fluorides. Calcium fluoride, cryolite, very very important. We are using, already we discussed in the electrolysis of the alumina. To extract alumina we use cryolite. Cryolite is increase the conductivity of the aluminum salt, aluminum reduction easily. Next is the fluoroapatite. Fluoroapatite nothing but Ca3 calcium phosphate, calcium fluoride only. Remember fluorospar, cryolite, very very important. They are the main source of the fluorine. Fluorine also available in the water and soil also is there. You know where the fluorosis will come now. If you take the trace of water, fluorosis will come. That fluorosis because of the fluorine only. Teeth decaying also takes place. No. Next one is the small quantity of the are present in the soil, rivers, water, plants, and bones and teeth of the animals. Clear is there, no? So these are fluorine is there. Next one, seawater contain chlorine, bromine, and iodine of sodium, potassium, magnesium, and calcium salts are there. But it's mainly sodium chloride is available. That mainly sodium chloride is available only. We discuss about sodium chloride only now. So next one is the general electronic configuration only. Look at there here, atomic number is 9. Fluorine, electron configuration helium 2s2 2p5. Group 17, period second period only. Look at the second period. Look like so this 2 is second period. 3 means third period. 4 means fourth period. 5 means fifth period. 6 means sixth period only. Look at it, these are the atomic numbers are there. These atomic numbers, these are the electronic configuration of these elements only. Students here do 1 point remember is there, no? Generally 1 point remember here. This mention not mentioned here. Clear students here. Just imagine here, if you take here general bromine is there, no? Bromine is available as silver bromide. Bromine is available as a silver bromide. And also here consider the iodine is available as a calci. And also that's also called as a child saltpeter. Child saltpeter formula is sodium NaIO3. NaIO3 this is called as a child saltpeter. That's available of the iodine only. This is called seaweeds. What seaweeds means now here considered some plants which are located in the oceans are there. That ocean containing of iodine. Do you know where deficiency of iodine causes the goiter disease only. deficiency of iodine causes a goiter disease only. Next one is how the halogens exist. You know very well I said already discussed that the halogens are 1 electron deficient only. Look at the fluorine I am taking, the fluorine containing of the 2 shells will be there. 2 shells are there. Look at how many electrons are there. 1, 2, 3, 4, 5, 6, 7. So if you want it is gain 1 electron, it in the octet configuration. In order octet configuration, 2 fluorine atoms are combined, they form a F2 molecule. F2 molecule. Look at here how many electrons are the outermost shell. 1, 2, 3, 4, 5, 6, 7, 8. 8 electrons are there. So it's contain 8 electrons only, that's stable electron configuration. All halogen atoms require 1 more electron to attain the octet configuration, stable electronic configuration, 8 electrons. So each atom can achieve by sharing of 1 electron with another atom from single bond only. So what happens there, the F2 molecule form single bond, Cl2 molecule form single bond, Br2 molecule form single bond, I2 molecule single bond. So all these halogens exist as a diatomic molecule. There are as a diatomic molecules only. Next one is the look at the melting point, boiling point of the halogens. We take the generally we take the melting point, boiling point of halogens are there. No, generally halogens are generally have a low melting point, boiling point is there. Fluorine is a gas, bromine is liquid, iodine is under sublimation only. So all these have generally having a low melting point and boiling point only. They mention here the details is there. Here consider there no fluorine is there. The melting point is minus 20 to 20 degrees Celsius only. Here boiling point is minus 100 degrees Celsius only. Chlorine is minus 101. Here minus 34 degrees. So regarding these data is no need to remember. That's one is not required. Then students will go for next one is there. Look at next one is the physical properties of halogens. Very very important. Physical properties of the halogens only. What are physical properties we are going to discuss in detail is ionization energy. What is ionization energy? The minimum amount of energy is required to remove the electrons from the outermost shell is called ionization energy. Next one is electron affinity. Electron affinity, that is tendency to accept electrons only. Electronegative, nothing but the tendency of to attract the bond pair of electrons. Bond pair of electron is there. Next one, oxidizing properties, oxidizing state, oxidizing properties. Metals reaction with the metals is there now, and reaction with the non-metals, hydrogens we will discuss in detail. Let's have discussion regarding the here. Look at the first one, ionization energy. Generally, what is ionization energy here? The minimum amount is there. The ionization energy is defined as the amount of energy is required to remove the most loose valence electron of isolated gas atom. Look at if you take one atom is isolated gas atom, if you remove one electron, how much amount of energy required? That energy is called ionization energy only. Generally, halogens having highest ionization energy. Why highest ionization energy? Generally, they have 8 electrons, they have 7 electrons are there, no? So they cannot, they doesn't want to lose any electron from outermost shell. They always try to attain octet configuration is there, no? That's the reason why they have the highest ionization energy only. If the outermost shell, look at if the outer valence electrons are far away from the nucleus, it does not take as much energy to remove the electrons. Look at suppose you got one point remember, in the group ionization energy values decreases. Why ionization energy value increases means decrease means the number of energy levels are increases. Fluorine contain 2 energy levels are there. No? Look at if you have any doubt is there here, and this point is there. I'll explain one small idea is there. Look at consider look at this contain valence electron in the second energy level. Here valence electron third energy level. Here valence electron fourth energy level. Here valence electron fifth energy. Here sixth is there. What happens? The number of shells increases. Number of shells increases means you can easily remove the electrons from the outermost shell. So what happens? The nuclear force will decrease. So number of shells increases. The nuclear force of attraction decreases. We can remove the electrons easily from the outermost valence shell. So that's the reason why when the group ionization energy value always increases. In the group ionization energy values always increases. Look at you got very clear idea. Then look at here the container 2,7. 2 cells, 2 shells are here. 3 shells are here. 4 shells will be there. So they can easily remove electrons from the. So next one is students look at this one is there. No, here I very mentioned very clearly only. Next one is also the highest ionization energy makes the element appear non-metallic nature only. Iodine has the and highest when displays the metallic property only. Look at it, I said very clearly when the wave code down of the period table is in the group in the halogen family. General ionization energy value decreases. Ionization energy value decreases means no metallic properties are predominant than the non-metallic properties. So clear. Next one is the consider. Next one is constituents of the next one point is then here. Look at there. Next one is the electronegativity. What is electronegativity? The electronegativity is nothing but the tendency of to accept electrons only. Okay, it is measure the tendency of an atom to attract the bond pair of electrons towards itself only. So look at students, just consider that if you take the two fluorine atom, the two fluorine atom have equal tendency to accept electron. You know very well here the one bond means two electrons are there. So consider the two electron pairs are equal share. If suppose if you take the fluorine and hydrogen, what happened there? Fluorine is more electronegative atom. Why fluorine more electronegative atom means, remember one point I will say, fluorine atomic number 9, it's containing of the 9 protons. Hydrogen contains single proton only, you know. So 9 proton attract to the bond pair electron towards itself. So what happened there? The electrons moves towards the fluorine. So fluorine gets the partially negative charge, and here the hydrogen gets partially positive charge. Partial negative charge delta only, and here the partially positive charge. Partial positive charge only. Next, the valence electrons will be at the distance from the nucleus as we go down of the group only, and therefore the nuclear and the electrons are not much attractive. You know very well. Now consider when you first suppose you look at it and just consider this one shell. Fluorine, you consider the fluorine is containing two shells are there. Okay, now if you go for iodine, is there number of shells more will be there. So when our number of shells is more, no, the nuclear force of attraction will be look at there. The nuclear force of attraction will be look at on the outermost shell will be decreased only. So what I mean there is the electrons are not attract much stronger as compared with the like fluorine. So that's reason why. That's the reason why is there no, when look at the consider that the valence electrons will be the distance from the nucleus as move down of the group. The nuclear force of attraction decreases, ionization energy value will decrease only. The electronegativity also will be decreased only. Okay, electronegativity also will be decreased only. Next one is here the electronegativity decrease in the group, decrease down of the group because of the increasing of the number of valence shells, and also and decreasing of the nuclear force of attraction the outermost shell. So this way look at the electronegativity level decreases only. One point remember, fluorine is the most electronegative element in the periodic table. I'm saying once again, fluorine is the most electronegative element in the periodic table only. Okay, next one is the look at students consider the one point is then electron affinity. What is electron affinity? Is it decrease down the group only. Electron affinity means here the electron affinity of an element or an electron affinity of an atom or molecule is the amount of energy releases here. The amount of energy releases here, consider the energy releases as spent when the electron is added to a neutral gas atom or a molecule. Suppose if you add the one electron for neutral gas atom, here some amount of energy releases only. You may ask question, sir, how amount of energy releases means? You know very well, halogens are one electron deficient. When electron is gains, it becomes more stable electronic configuration. More stable molecules means it releases some amount of energy. You know, one point remember, more energy, less stable, less energy, more stable. So that's the reason why whenever we add electron, it releases some amount of energy only. Since the atomic size is increased down the group, the electron affinity generally decreases group only. Look at consider here there now when you go for the down of the group, electron affinity decreases only. One point remember students for board examination, when compared with the fluorine having low electron affinity. You may ask questions, sir, how is it possible means? Remember here just consider here the two shells are there. If you add one electron, you have to add the p orbital. P orbital, how many electrons are there? 5 electrons are there. 5 electrons means, so consider that whenever you add the electrons is there, no? These 5 electrons, first one is remember attraction force and repulsion forces are there. In this one here, repulsion force are more predominant because of small size only. It will not take easily. When you come into chlorine is there, here 3d orbital is vacant is there. And also this one is the third period is there, no? So what happens here, consider because of here 3d orbital is available, vacant orbital is available. So the incoming electrons are not much repulsion when compared to attraction forces. Okay, when repulsion forces are very less. That's the reason why chlorine readily takes more electron affinity when compared with the fluorine only. Clearly, once again I'm saying very important. Here fluorine is because of small atomic size, and nuclear attraction forces are predominant by the repulsion force of the electrons. Here nuclear attraction forces are more predominant than the repulsion force. That's the reason why chlorine having the highest electron affinity when compared with the fluorine. When compared with the fluorine have the highest electron affinity. Because however fluorine has low electron affinity than the chlorine, and this can be explained by the small size of the fluorine compared with the chlorine. When compared with the fluorine has small size only. That's the reason why it cannot take electrons easily only. Next is the oxidizing of the halogens. Then consider the fluorine always available -1 because of small size only. Fluorine never loses electrons. Fluorine more electronegative atom is than fluorine always -1 only. But chlorine, bromine, iodine, astatine, they have the d orbital is available. D orbital is available. Look at the students, consider that here D orbital is not available, here D orbital is available. Because of available D orbital only, fluorine is -1, chlorine 1 is -1 to +7, bromine also -1 to +7. So they will exhibit a variable oxidation state. Chlorine, bromine, iodine, acetylene exhibit the variable oxidation state, but fluorine will exhibit only single oxidation state is -1. Okay, single oxidation is -1. So here look at the chlorine is there -1, +1, +3, +5, +7. Look at the odd numbers will come. 1, 3, 5, 7 odd numbers will come. Here bromine also -1, +1, 3, 4, 5 will come. 3, 4, 5 is there. Iodine is there -1, +1, +5, +7 will be there. Acetylene is there -1, +5, +3, +5, +3, +5, +7. In sodium chloride, sodium is +1, you know very well, chlorine is Cl-. Clear? If you take the here, consider the HOCl is there, chlorine is +1 will come. Chlorine +1 is BF3. Look at the BF3 is called intrahalogen compounds on there. In this one is when compared with the fluorine, bromine is the fluorine is more electron atom. More electron atom is -1. Always in -1. Look at the consider here the X plus 3 minus 1 is equal to 0. Look at students, I mentioned X is there. I want to find the oxidation number of bromine is X. 3 fluorine atoms are there. 3 are taken. Each fluorine atom oxidation number is -1 is equal to 0. You know very well after this one is then consider the X is equal to -3 is equal to +3 will come, no? So that's why bromine is +3. Do you know very well how to find the oxidation number? HClO3 is then if you find +1, 5 will come. I of 7 is the oxidation number, +1 will come. So that's the reason why because of availability of D orbital is there, halogens exhibit the variable oxidation states only. Variable oxidation states only. Next one is oxidizing power only. General oxidizing power decreases in the group only. Oxidizing power decrease in the group only. The halogens are strongest oxidizing agents. General halogens are strongest oxidizing agent only. The oxidizing power decreases from the fluorine to iodine only. Because why oxidizing power decreases? Fluorine is small atomic size only, it can easily attract the electrons. You go for iodine is a large atomic size, it cannot attract the electrons easily. So generally it oxidizing, look at the fluorine is the strongest oxidizing agent. It oxidizes other halogen ion to halogen. Look at the consider I'm taking the fluorine atom is there. If you take the chlorine, bromine, iodine, whatever maybe except fluorine is there. Fluorine react with this one is there. Consider the fluorine gains whatever the excess amount of electrons from here is there. It will take the form a 2F minus. And you see here the X minus is then become X2 gas. Here X is maybe chlorine, bromine, iodine. So what happened there? Fluorine strongest oxidizing agent, it can oxidize halogens also. If you take the fluorine gas when you pass through the water, oxygen gas liberated. Oxygen gas will come outside. So what I mean there halogens is there, that's one stronger oxidation. Halogens of low atomic number oxidize the halide ion higher atomic number. It means to consider the fluorine is lower atomic number only, it can oxidize the higher atomic number of the chlorine, bromine, iodine, acetylene. Look at the simple problem experiment they have taken is then look at the consider I'm taking the here iodine solution is there. Because of 2I minus is there, colorless is there. If you pass the chlorine gas to the solution, what happens the after chlorine gas, Cl2 gas back onto the Cl minus and iodine gas. Iodine is there, no? Iodine in the form of, look at the iodine, what happens just consider violet color will come, no? That's only. Chlorine is the strongest oxidizing agent than iodine. Chlorine will be the displaces the I minus from the solutions only. Okay, no, I minus from the solutions only. That's the reason only. It's very, very important. Okay, then students, the oxidizing or reduction is there. Look at the consider the Cl2 is there, no? 2Br minus, Br2 and Cl2 only. Clear? This one only. I said very clear only, no? So next one is then here. How does the electronic structure affect the reactivity only? Okay, no? Electron structure affect the reactivity only. Reactivity to alkali metals decrease down the group only. React to the alkali metals decrease down the group one. So students, before I'm going to discuss about the chemical property, first you have the atomic size only. Generally what happens is the atomic size increase down the group only. Atomic size increase down the group because of the increasing of the number of shells. Because of increasing the number of cells, atomic size will be increases only. Clear is there, no? Next one is if you want to calculate atomic radius is there, no? Internuclear distance only. If you take some other atoms are there, no? If you take some other atoms, so I will draw the diagram. If you take this is the two atoms are the equal size will be there, no? In the internuclear distance is called, no? That's called atomic radii only. That's called atomic radii. One point remember, generally halogens having the smallest atomic radii when compared to the remaining element in the periodic table. In that one is there, no? Here atomic radii of this element is there, you can calculate by this one only. You know very well, halogens are diatomic molecule. Halogens are diatomic molecule. Atomic radii will be calculated the half of the internuclear distance between the two atoms. Okay, half of internuclear distance between the two atoms only. Okay, number one point is that in the group is the atomic radii increases. In the group atomic radii increases. In the period atomic radii will be decrease only. In the period atomic radii will be decrease only. The ionization energy will depend upon the atomic radii. I discussed yesterday, no, when a higher atomic size will be there, no, you can easily lose electrons. Small atomic size will be rather uses easy electrons only. I already mentioned one point is then here. When fluorine is there, no, if you add electrons here, what are more repulsion will be there. But if you want to add electrons are easy. Here if you want to add electrons here more easy. Here is electron. That's the reason why is there no electron affinity is there no chlorine is more when compared with fluorine one. Clear students here? You may ask questions, sir. Chlorine and bromine iodine is there no? In this electron affinity iodine is more. It's not correct. Why? Because of high atomic size, it cannot pull electrons very strongly. It cannot pull electrons very strongly only. That's something. But here the next one is there no bond dissociation energy. What coming to bond dissociation energy is then look at here, consider the two fluorine atoms are there no, both fluorine atoms are very close to each other. Because of small atomic size, more repulsions will be possible. The bond dissociation energy of the fluorine is less when compared with the chlorine. Chlorine is there no less when compared with the bromine. Bromine is less when compared with the iodine. So what I mean when atomic size increases, repulsions are decreases, bond dissociation energy value is increases only. Because in the group what happened there, bond dissociation energies increases only. Bond dissociation energy increases only. These are the general properties, physical properties of the halogens. Let's start about the chemical properties of halogens in detail.